Hello and welcome to the channel. Even this age of foundation models that can produce diverse content, advanced speech recognition remains highly relevant. This technology is not only driving key functions across sectors like healthcare and fintech, helping with tasks like transcription, but it is also powering very capable multimodal AI systems. Last year, OpenAI really rocked this field with its own Whisper model, and we have seen since then that Whisper has become a de facto standard in heaps of technologies and AI powered applications across the globe. This Whisper model converted user audio into text, enabling an LLM to process the query and provide the answer, which was again converted back to speech. Due to its ability to process complex speech with different languages and accents in almost real time, Whisper has emerged as the gold standard in speech recognition, whereat it has already been downloaded more than 5 million downloads every month. Just let it sink. But what if a model can recognize and transcribe speech even faster than Whisper? And that is what this new model, Whisper Medusa, is trying to claim. And interestingly enough, Medusa is a figure from Greek mythology. She was a monster and one of the three Gorgon sisters with snakes for hair and the ability to turn people to stone with a single glance. Medusa stands for strength, power, and production, and that is where this Whisper Medusa is trying to build upon to increase the performance of existing Whisper model. Whisper Medusa is an advanced encoder decoder model for speech transcription and translation, processing audio through encoding and decoding stages. Given its large size and slow inference speeds, various optimization strategies like faster whisper and speculative decoding have been proposed to enhance the performance of OpenAI's Whisper model, and that is where this new Medusa Whisper builds on Whisper by predicting multiple tokens per iteration, which significantly improves speed with small degradation in WER. They have trained and evaluated their model on the Libri speech dataset, demonstrating speed performance. In this video, we are going to install it locally and then we will be using a simple audio file to do the transcription. Before I show you the installation, let me give a huge shout out to Mast Compute who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on affordable prices, I will drop the link to their website in video's description. Plus, you will also get a coupon code of 50% discount on a range of GPUs. Another thing I wanted to share is that this speech recognition with Whisper Medusa is of very high quality training packed. When training Whisper Medusa, they employed a machine learning approach called weak supervision. As part of this, it froze the main component of Whisper and used audio transcriptions generated by the model as labels to train additional token prediction modules. This is really unique and this is really amazing as they chose to train their model to predict 10 tokens on each pass, achieving a substantial speed up while retaining accuracy. But the same approach can be used to predict any arbitrary number of tokens in each step. Since the Whisper model's decoder processes the entire speech audio at once rather than segment by segment, this new method reduces the need for multiple passes through the data and efficiently speeds things up. And that is why it is faster than Whisper. Okay, enough talk. Let's go and install it. This is my Ubuntu system where I'm running this Ubuntu 22.04 and I will be using NVIDIA GPU card RTX A6000 with 48 GB of VRAM. First up, let me create a Conda environment where I will keep everything separate. I'm calling it Medusa with Python 3.11. Let's wait for it to finish installing. Now let's install some of the prerequisites, which include Torch and Torch Audio and Torch Vision. Let's wait for it to get installed. And that is all done. Now let's git clone the repo of this Whisper Medusa. Sorry, not this one. Let me put the proper command. Let me git clone Medusa and that is done. And I have also entered into that. Let's install all the prerequisites from here. It is going to take a bit of a time. And that is all done. Now let me install and trigger my Jupyter notebook where we will be downloading this model, and then we will play around with it. And the Jupyter notebook has been launched in a browser. Now let me show you the code which is going to download the model, and then we will also give it a sample audio. Before that, let me try to explain how this code is working. So first we are simply importing these libraries. Then I am getting this Whisper Medusa model and its packages from the repo which we have just cloned. We are specifying the model names and its repo from Hugging Face, and then from there I'm just giving it the path to a local audio file on my local system, and I'm specifying sampling rate as 16,000. Sampling rate is the number of times per second that an audio signal is measured and recorded. It is a fundamental concept in digital audio processing, by the way, and it determines how often the audio signal is sampled or captured, and it is measured in hertz. A higher sampling rate means more frequent samples, resulting in more accurate representation of the audio signal. Okay, so here we are setting it to 16,000 hertz or 16 kilohertz, which is a relatively low sampling rate, and we are just doing for speech recognition. And because this value focuses on capturing the frequency range of human speech, and the frequency range of human speech is between 100 hertz to 8 kilohertz, so that is why this value is more than okay. Okay, so that is done. English is the language here. We are, because I'm using NVIDIA's GPU, so I'm specifying CUDA, but you can even use CPU with it. There might be slower, but it will work. And then we are simply getting the torch audio from the path, specifying the sampling rate, and then we are passing this as an input to the model, and then receiving the output generated by the model, and then we are predicting it or printing it. So let me run this code and see how it goes. And you can see that it has started downloading the model. First chart is being downloaded, so let's wait for it to get completed. And model is not that huge, around I would say 6.5, that sort of figure. And the model is downloaded, as you can see, with the tokenizer and all the special tokens. And this is the transcription which it has done from the audio. Perfectly fine, because this is what I have said in the that audio, which is a very small wave file, and the speed is simply awesome. As an another example, I have just given it an MP3 file here now. This is just a small paragraph from this book, and let's see how it goes. I'm just running it. It is going to download the load the model on GPU, all the shards, and then it is going to do the inference from that MP3 file. And I will let it run just to show you the speed of it. There you go. So it has given us this whole chapter from the, because I'm just printing out 440 max tokens. If you want, you can print more, but you can see that it was so quick that it has simply um, got the transcription in a jiffy. So all in all, real good stuff. I think it lives up to its name, Medusa. I will drop the link to it in video's description. Play around with it and let me know what do you think. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. And the code which I have used, I'm going to put it in my blog and I will drop the link in video's description. So enjoy. Thanks for watching.